exercise number 12. This is on to determine tachometric constants of a tachometer. You know, tachometer is an instrument where we can measure the horizontal distance without using any chain or tape, right? So here in tachometer, the horizontal distance d is given by the equation for an horizontal side. The horizontal distance d is given by the equation Ks plus C. Now what is this K and what is this C and what is this S? Where K is called the multiplicative constant and C is called the additive constant. And S is the staff intercept. This we know. Using the staff intercept, that is the distance between upper stadia and lower stadia, the difference between the upper stadia and lower stadia is the staff intercept. And K is the multiplicative constant of an instrument and C is the additive constant of an instrument. Now we have to find this multiplicative constant and this additive constant C. These two constants we have to find in the field for this particular instrument. How to find this K and C? Right? That is our question. That is the aim of the today's exercise. Finding the multiplicative constant and additive constant. Let us go to the field and let us start finding out the value of K and C. Now let us go with the field procedure. How we are going to determine. First what you are supposed to do is select a level ground. Select a level ground. After selecting the level ground, mark a distance of, this is a 0 distance, this is 10 meter, 20 meter, or you can select 5 meter, 5 meter, 10 meter, 15 meter and 20 meter on a level ground, right? This is the 0 chain edge, 5 meter, 10 meter, 15 meter, 20 meter. Using the tape, right? Divide the ground into 4 parts, 4 parts. Understood? Now place the tachometer over the station O. At 0 chain edge, place the tachometer. Do all the temporary adjustments. The temporary adjustments, as you know, the centering, leveling, focusing and removing parallax. Temporary adjustments which you have to make over the station O. After making all the temporary adjustments over the station O, place the leveling staff at 5 meter. Place the leveling staff at 5 meter and take the stadia readings. We are going to measure the upper stadia, lower stadia and central crosshair reading. Note down the upper stadia reading and lower stadia reading. The difference between upper stadia reading and lower stadia reading is S1. Okay. Note down, this is distance D1. Let us take this distance as D1 is equal to 5 meter. At distance D1 is equal to 5 meter, note down the S1 reading. S1 is the difference between the upper stadia and lower stadia reading. Now shift the leveling staff to second station at 10 meter. Place the leveling staff at 10 meter. Right? And once again, note down the stadia reading. The upper stadia reading, central crosshair reading and lower stadia reading. Let the distance D2 be 10 meter and the staff intercept, the difference between upper stadia and lower stadia, S2 you find out. Then once again place the staff over 15 meter, at 15 meter. Now once again note down the staff intercept, upper stadia reading, lower stadia reading and central crosshair reading. Okay, the difference between upper stadia reading and lower stadia reading is S3, this is S2, this is S1. Now the distance D3 is 15 meter and S3 you note down. Then place the staff at 20 meter. Same procedure you follow. Upper stadia reading, lower stadia reading and central crosshair reading. Let this be S4. Right? At different intervals, at 5 meter, note down the staff intercept. At 10 meter, note down the staff intercept. At 15 meter, note down the staff intercept. At 20 meter, note down the staff intercept. Before noting down the staff intercept, before starting the exercise, after doing temporary adjustments, you have to make the vertical angle 0 degree, 0 minute, 0 seconds. You have to make the theodolite level, right? Then only you can take the staff intercepts. Don't make any inclined side. Let us have a horizontal side. To have a horizontal side, you have to make the vertical angle 0 degree, 0 minutes, 0 seconds. And then you have to take the staff intercepts. Understood? So what are the observations which we are going to make in the field? So first what you have to do, select a level line, divide this into different distances, the land 0, 5 meter, 10 meter, 15 meter, 20 meter you mark on the ground. After marking these distances of equal intervals on the ground, place the tachometer over the station O, do all the temporary adjustments and make vertical angle 0 degree, 0 minute, 0 second. That is very, very important. After making the vertical angle 0 degree, 0 minute, 0 seconds, then place the staff at 5 meter, take the staff intercept. What is the staff intercept? Staff intercept is the difference between the upper stadia and lower stadia reading. These are the upper stadia and this is lower stadia. This is central crosshair reading. This is central crosshair. Note down the corresponding reading of the staff reading at the upper stadia. Note down the corresponding reading at the staff at the lower stadia. Right? The difference between these two readings, that is S1. Similarly, find out the staff intercepts at 10 meter, find out the staff intercept at 15 meter and find out the staff intercept 20 meter. Let the staff intercepts be S1, S2, S3, S4. And what are the distances? This is D1, this is D2. Now the D2 is equal to 10 meter. Similarly, D3 is equal to 15 meter. D3 is equal to 15 meter. And D4 is equal to 20 meter. D4 is equal to 20 meter. D4 is equal to 20 meter. So after noting down D1, D2, D3 and D4, so D4 is equal to 20 meter and S4 you have to find. Right? So these are the observations you have to make it on the field. After making all the observations, we are going to solve the two sets of simultaneous equations you are going to prepare. Right? We are going to form a simultaneous equations. That is using the formula D is equal to Ks plus C. We are going to frame a simultaneous equations and we will solve the simultaneous equations and then we will find K and C. So let us do the calculations after obtaining the field data. Okay. Now we will go to the field and we will conduct the exercise and then we will come back and we will do the calculations for K and C. Okay. Okay, now let us do the field exercise. First, we are going to select a level line. The objective of the study, as already you know, the determining the constants of a tachometer. That is multiplying constant and additive constant. That is K and C we have to find. First we have to select a level line. After selecting a level land, divide this into 4 parts. This is a 0 chain edge. This is a 0 chain edge. This is a 5 meter. Next, the 10 meter. This is 5 meter. You have 10 meter, 15 meter and 20 meter. Like this, divide the line into 4 parts, 5 meter, 10 meter, 15 meter and 20 meter using a tape. After dividing this into 4 parts, now at 5 meter, place a leveling staff and take the staff intercepts. At 10 meter, place a leveling staff and take the staff intercept. At 15 meter, place the leveling staff and take a staff intercept. And at 20 meter, take the staff intercept. Right? The staff intercept is nothing but the difference between the upper stadia and the lower stadia. Let us start finding out the readings. Before finding out the readings, set the theodolite over station 0 at 0 chain edge. Set the tachometer over the 0 chain edge. Do all the temporary adjustments, the centering, leveling and removing parallax. All temporary adjustments already been done. I have set the theodolite or set the tachometer over the station O. And I have made the vertical angle 0 degree, 0 minutes, 0 seconds both in vernier C and vernier D. Both vernier C and vernier D, the vertical angle is 0 degree, 0 minutes, 0 seconds. Right? Now place the staff at 5 meter and take the staff intercepts, the upper stadia reading and the lower stadia reading. Bisect the staff, make the crosshairs visible. We have already removed the parallax. The lower stadia reading is at 5 meter, 1.225. The upper stadia reading is 1.525. The lower stadia reading is 1.475 and the upper stadia reading is 1.525 at 5 meter. Then move to 10 meter. Place the staff at 10 meter. Next at 15 meter. Okay, at 20 meter. Okay, at 20 meter it is 1.615 is the lower stadia reading and upper stadia reading is 1.820. 1.820. So like this, we are going to take the upper stadia and lower stadia reading at all the 4 stations at 5 meter, 10 meter, 15 meter and 20 meter. After taking all the readings, now we have to find out the staff intercepts. That is the difference between upper stadia and lower stadia at all the stations. Okay. After finding the staff intercepts at all the stations, let us do the calculations in the class. Already we have done the field measurements. After making the field measurements, these are the staff intercepts. All the staff intercepts we have calculated in the field. S1 at distance D1, the staff intercept S1 is 0.050 meter. That is, upper stadia is 1.525, lower stadia is 1.475. The difference between the upper and lower stadia is 0.050. This is S1. Similarly, S2, the staff intercept at station 2 is 0.100 and the staff intercept at station 3, S3 is 0.250 and staff intercept at station 4 is 0.305. These are the staff reading at different stations, right? So, we know the distance D1, we know S1, we know D2, we know S2, we know D3, we know S3, we know D4 and we know S4. Now, let us frame the simultaneous equations. D1 is equal to KS1 plus C. Now, the value of D1, this is a formula for finding the horizontal distance D for an horizontal site. The D1 is 5, K, we don't know the value of K, this K we have to find out. S1 is 0.050 plus C, the C also we have to find out. Therefore, the equation will become 0.050 K plus C is equal to 5. Call this as equation number 1. Similarly, considering D2 and S2, D2 is equal to KS2 plus C. Now, distance D2 is equal to 10 meter. The constant K, keep as it is. S2 is 0.100 plus C. The equation you can write it like this, 0.100 K plus C is equal to 10. Call this as equation number 2. Now, we have two equations, equation 1 and equation 2. These two equations we have to solve simultaneously, right? Similarly, you can frame another two set of equations for D3 and D4. First, let us solve these two simultaneous equations. Let us see the value of K and C, what we are going to get. So, I will subtract equation 2 from, or equation 1 from equation 2. I will subtract equation 1 from equation 2. That is 0.100 K plus C is equal to 10. This is equation 2. 0.050 K plus C is equal to 5. Equation 1. I am going to subtract these two equations. Plus sign and minus sign get cancelled. This will be 0.050 K is equal to 10 minus 5 is 5. Therefore, K is equal to 5 divided by 0.050. 5 divided by 0.050 is 100. Now, we got the multiplicative constant K as 100. Now, we have to find the C value. K value already we have found out. Now, I want to find the value of C. Substitute the value of k in any of the equation. Substitute k is equal to 100 in equation 1 or equation 2. I will substitute k is equal to 100 in equation 1, that is 0.050 k plus c is equal to 5. 0.050 into k is 100 plus c is equal to 5. So 0.050 into 100, this will be 5 plus c is equal to 5. C is equal to 5 minus 5. The additive constant c is equal to 0. These are the one set of equations, one set of values, right? K value and c value we have calculated for the one set. Similarly, you have to do the calculation for k and c for the another set, for D3 and D4, right? So, after finding the value of k and c for the second set, you have to take the average of these k and c value from first set of equation, and for second set of equation, you have to take the average values of k and c, right? That will be the final answer.